options in terms of runoff, evapotranspiration and other things. But there are some limitations are also associated with these hydrological models. And some significant limitations are basically interventional flow, like how you are going to model your water storage structures or major reservoirs in your hydrological model. Of course, in some hydrological models we have provision of doing this. There are some models which are open source where user can plug in their reservoir model and other things. The main limitation is how we are going to account these water bodies or major reservoirs. And with this background, we have derived objectives like to incorporate major reservoirs in hydrological model with its hydraulic particulars and as well as roll curves. And our second objective is representing major reservoirs alone may not yield good stream flow modeling. There are some other medium to small water bodies are available, which need to be taken care in order to get good stream flow model. So we have taken up reservoir Ujjaini as our study area since it is highly abstracted catchment. It is basically in upper Bhima subbasin of Krishna basin. So here if you see reservoir Ujjaini is abstracted by two major reservoirs. One is Manikdo and another one is reservoir Kadagavasala. So even after accounting this major reservoir, there are about 20 medium-sized reservoirs are available and more than 7,000 water bodies are available. So we need to correct our stream flow for this upstream abstraction in order to avoid accuracies or inconsistencies in the stream flow prediction. So we have taken up BAC hydrological model. It's a variable infiltration capacity hydrological model. It's an open source, physical based, semi-distributed hydrological model. The uniqueness of the model is it will give you the subsurface soil profile, which will be highly useful for agriculture and other applications. Since the model is a grid-based model, if the user can give their inputs on grid and water balance components will be computed on grid-wise. So we need to give some kind of inputs in terms of vegetation phenology, in terms of leaf area index, root fraction and other things. And as well as soil hydraulic particulars also we need to define in the model. This is where the exact theme of this symposium is came into picture, like data to intelligence. How we are putting our geospatial data in the model to for various applications. And also we have used meteorological data in terms of temperature and rainfall. We have taken from IMD since it is consistent and reliable data. So this is how the model framework is made. And this is the reservoir representation module which is developed jointly by us and University of Singapore. Basically this model will help you to represent your major reservoirs in a hydrological model. Basically, a user can define their reservoir in the model. Like we can define where the hydraulic structure is present, how many open water classes are there in the model, and what is the flow direction of your particular catchment basically. So you need to properly delineate the cascade effect of one reservoir to other reservoir in order to take care of reservoir flow direction. So there are some simple water balance equations are associated here. Basically it is this reservoir model will work based on the rule curve you are going to provide. What is the operational strategy or what is the operational policy of your reservoir? Basically whether you are releasing water on a daily basis or whether you are releasing on a monthly targeted water level, or is there any predefined releases or like that. So once you have defined your operational policy or operational rule curve in the model will follow the simple water balance equation, that is whenever my live storage is less than depth storage, it won't release any water. Whenever you are getting inflow, basically inflow minus outflow, if it is more, your inflow is more, it will check for the reservoir operational rule curve. If it is less than the live storage, it will release the excess water, and this excess water will reach the downstream or next reservoir in the cascade system of reservoir. So we have used this technology and we have applied this over Krishna basin. Let me take a few minutes to explain the geography of this Krishna basin. Basically, if you see the reservoir Almaty and Narayanpur are located at the upstream, And if you go down, reservoirs like Srisailam and Nagarjuna Sagar, they are highly abstracted. If you see reservoir like Almaty and Narayanpur, they are also abstracted, but with a very few reservoirs. So these major reservoirs we can easily taken care in the reservoir representation module. Whereas reservoirs like Srisailam and Nagarjuna Sagar, they are highly abstracted by medium-sized reservoirs or water bodies. For that, we have developed another methodology called storage correction factor. Let me show you the results of reservoir Almaty and Narayanpur. So this is the current season, this 2022 monsoon results of reservoir Almaty after incorporation of our reservoir representation module. We have a good match with the observed one in terms of graphically as well as statistically. And again, if you see Narayanpur also, we have good match with the observed one if you consider major reservoirs. But this is Tungabhadra and this is Srisailam. See, as we move downwards, as we progress towards downwards, you have so much of abstractions. Once you have so much of abstractions, if you see the early period between June to July, there is no good match between observed and simulated. This is because of the storage, upstream storage effect. So this, for reservoirs like this, we cannot simply go with the reservoir module. So we have developed a method called storage correction factor, which will take care of your medium water bodies and other reservoirs. So basically, this is a relationship between your catchment rainfall versus storage. So basically, based on the cumulative rainfall, you are going to categorize your catchment into dry, damp, or damp to wet, or wet. It depends on your catchment condition. So with the help of rainfall and the storage, we have developed a regression model and we have found intercepts. And we applied these intercepts as a storage correction factor for our simulated inflow. So this is the overall methodology. First, we need to develop your hierarchical model, and you need to do routing model with the reservoir representation module, and the simulated model will be corrected for medium and small size reservoirs. And this is a result for reservoir Ujjaini for the last decade. So first graph talks about only if you consider major reservoirs in the catchment, and the reservoir graph B talks about the medium to small size reservoirs when you account. So if you see the results, after correcting your stream flow for its abstractions, results are highly improved graphically as well as statistically. So to conclude, we have incorporated major reservoirs in our hierarchical model using reservoir representation module, and this alone will not solve the problem. So we have gone for the storage correction factor to correct for medium and small water bodies. Once you have this integrated approach of correcting stream flow, you can use this model for inflow forecast or stream flow forecast or better water resource management, and it will be useful for stakeholders also. Thank you.
The entire catchment without, it's a bare earth model actually they are using, and they are not considering any, storage in the reservoir. It's a very important study. Any
So in our Bhuvan NHP portal, we are sharing this information basically.
Because
we have validated the results across many basins, and we found good results in Krishna.
okay, but I have seen this Usman Sagar and even Hussain Sagar and all. There also the management is not that way, the way you have just now shown with the all datas and all. And I think these corrective measures are required in such places also.
Yes, in such cases, rainfall also plays a huge role. So whenever we have maybe in some IMD week we may receive huge rainfall. In such cases, dam authorities have to revise their operational policy. They may release water to downstream. So in those aspects are also associated there.
Thank you.
Thank you. Yeah, one more question, please.
Well presentation, but I have got one question regarding any studies made on the siltation of Ujjain Dam reservoir.
Siltation, sir?
Siltation.
No, sir.
Consultation is
Because its capacity is about 100 TMC, then what is the present live capacity? Any studies?
Sir, actually, siltation is one another concern, but
parameters using SRTM 30 meters resolution, and the vegetation information we have taken, terrain parameters, terrain information we have taken here, and the climatic variability also we have taken into this concept. and using the conditional Latin hypercube technique and the machine learning tools, using the legacy data as well as the additional soil samples that were collected during the survey. We have used it into this to predict the soil properties of the entire Vidarbha region. And you see here, these are the areas where the legacy data is available and where the data is not available. Looking at the data limitations, so additional minimum samples identified here using the conditional Latin hypercube. As I told you, the terrain parameters, 25 terrain parameters are considered here, including the elevation, slope, aspect of the slope, precision indices, and the bands, number of bands also we have used here, NR band, thermal bands, and the climatic total annual rainfall and surface temperatures. All the 25 parameters, terrain parameters we have used. These terrain parameters are very, very important to bring the soil variability because this is the base variability because when you go for soil survey, the base is the factors influencing the soil formation. As you already know, the soil scientist chloraptor model given by the Jenny, that is the base, that is the 10 commandments for the soil survey people, where the climate, organisms, the parent material, topography and the time, the 5 factors which are influencing the soil parameters that are considered from the terrain parameters. When you are sampling here, the sampling, wherever the samples are not present, where the sampling is not limited, and we have strategy in such a way that the population and the sample mean, wherever the sample is here, taken here. This is the methodology we have taken, the depth, because the soil information is in the natural formats. In the horizon information is there in the traditional soil survey, but the traditional information we are converting into the digital mode, that is 0 to 5, 5 to 15 and all. These are parameters, as I told you, these are the parameters that we are considering here. And these are various thematic properties maps we have generated from the point data using the machine learning tools. Some of the thematic maps I have given here: soil reaction, calcium carbonate, and the soil organ carbon, and the soil depth map I have given as a case study here. And what are the information we have generated here in the Vidarbha region, that we have bring it to the national soil grid. So in this national soil grid, this Vidarbha region we have done now, and earlier we have done this Bundelkhand also we have generated the soil information, and we are bringing it to the national soil grid where just by the click of the mouse, you can know each and every parcel of the soil information in terms of their chemical properties, in terms of their physical properties, and all. And these are validation data sets I have given here. Because it is a predicted map, digital soil map is a predicted map where a reasonable accuracy has been achieved in this project. These are the calibration model and the validation models I have given here. And based on the soil information, we have generated the land use plans. And this is the soil and water conservation plan we have developed for this region. And to conclude this, the key outcomes of this exercise are digital soil resource database, spatial soil and water conservation plan, soil site suitability, based soil land use plans we have generated for this region. The products will assist the farmers, planners and executors in meeting the developmental efforts, arresting the land degradation law, and finally the high resolution information, that is 30 meters resolution we have used here as SRTM data. And this information, thematic information generated through this rigorous exercise will act as a strong platform for enabling the transfer of technology at the right place for harnessing the potential of the natural resources of the Vidarbha region. And this technology, hybrid technology, where legacy data and the new sampling plan can be upscaled to the other regions, where we have more than 80 regions in India. Now we are thinking to apply this methodology for the rest of the pan India. Thank you, sir. Thank you.
Thank you.
Technology Misra. So today my topic of presentation is estimation of groundwater storage change at small basin scale using GRACE time series data, a case study from Subarnarekha River Basin, India. So we all know groundwater is a crucial element of the global water cycle, which helps in sustaining agricultural, domestic and other industrial activities. Hence it needs to be monitored. So over exploitation of groundwater with respect to population growth and climate change has a substantial depletion already globally. So it the continuous abstraction may further degrade the situation, so it required efficient monitoring. So the core objective of the study is to understand the groundwater storage change and its trend over the Subarnarekha River Basin, India. The Subarnarekha River Basin falls in the tropical region of eastern India and it passes through the states of Jharkhand, Orissa and West Bengal. The major tributaries are Kanchi, Karkari, Kharkai and Dulang. The annual average rainfall varies between 1200 to 1800 millimeter approximately. Geologically, the basin is divided into three formations, that is Precambrian, that is mostly cover the part of upper and middle parts of the basin, and the tertiary and quaternary formation, that is the lower part of the basin. So data used here is GRACE data, CSR GRACE data. From there we got the terrestrial water storage anomaly and global land data assimilation system, that is GLDS data. From there we got the soil moisture and surface runoff and TRMM data. We got the precipitation from there. All the data are global data having a spatial resolution of 0.25 degree. The time period is from 2003 to December 2016, that last 14 years. The methodology, we have used this is the overall methodology. So we have used CSR GRACE data, then GLDS, NOAA and TRMM data. The pre-processing and subsetting has been done. And from CSR data, we got the terrestrial water storage anomaly. And from GLDS data, we got the soil moisture anomaly and surface runoff anomaly. And from there, we got the groundwater storage anomaly. And finally, we have got the annual and seasonal groundwater storage map. And from there, we have used the Mann-Kendall test to calculate the trend, and we have compared the data with the rainfall. So the results shows that a decreasing trend in both the terrestrial water storage anomaly and groundwater storage anomaly at the rate of 0.31 millimeter per month and 0.22 millimeter per month. The seasonal decreasing trend is found in the TWSA at the rate of 2.65 millimeter per year in pre-monsoon and 9.2 millimeter per year in the post-monsoon. A decreasing trend is also found in the GWSA, which is 0.58 millimeter per year and 4.62 millimeter per year in the pre and post monsoon respectively. This is the spatial variation of TWSA and GWSA in the Subarnarekha River Basin. We can see from the map that figure 4 that annual average precipitation map of the basin, and it shows that the higher precipitation values are mostly lies in the lower part of the basin, and the GWSA at annual scale shows that the upper part of the basin is having higher negative values as compared to the lower part, where the major cities like Ranchi, Jamshedpur, Ghatsila, etc. fall, which is a good corresponds with the rainfall. This is the temporal variation of water storage with the rainfall. Here we can see a very good correspondence between the TWSA and GWSA with the rainfall. The years having the higher rainfall, such as 2007, 2008 and 2013,
हाँ बोला सर, good morning.
higher GWSA and TWSA values.
बोला ना सर.
And similarly, the years having lower rainfall like 2009, 2010, 2014.
Thank you sir. मी आता हैदराबादला आहे.
GWSA values.
नंतर कॉल करते.
These are the statistical results of the statistical trend analysis using Mann-Kendall test. The annual precipitation shows a very good 95% confidence interval significance with the 5.40 millimeter per year decrease in annual terrestrial water storage. Similarly, the groundwater storage also shows a insignificant decrease with minus 2.45 millimeter per year. Both the terrestrial water storage and groundwater storage anomaly shows a decrease in post monsoon. So, decreasing trend in TWSA and GWSA was found at the rate of 5.40 millimeter per year and 2.45 millimeter per year. This may be due to the change in the land cover dynamics of the significant basin area, which mostly affected by the urbanization, and the intense irrigation activities may also, like excessively groundwater draft can also cause for this decline in groundwater storage. The groundwater storage was found to be significantly low for the year 2010, which was also reported by the Verma et al. Over the Jharkhand. This might be the cause of the drought prevailing in that area in that time. So precipitation trend was observed to be increasing insignificantly during 2003 to 2016, whereas there has been a decreasing trend in TWSA and GWSA in the possibly due to the geological condition of the basin, where the lithology of the basin is mostly hard rock terrain, which may cause the higher surface runoff and minimum recharge possibilities. So further studies may be required to explore the impact of other climatic parameters such as temperature, evapotranspiration, etc., and other anthropogenic activities, so that we can understand the groundwater storage change scenarios.
Okay, thank you, Mr. Musa. Thank you very much.
And he will be giving the lead talk, and we have other eminent speakers who will be there publishing the papers. I have also given a task to evaluate the papers. Okay, we conduct 3 minutes presentation for the PhD and PG students. Out of that, in IEEE we give prizes, and I will tell you, because I am a new guy, that madam told about payload sensors and all. I was only the other part in using those for data for other applications. The decision to fly a payload within 3 months from design to this is decided based on the 3 minutes presentations whatever the students have made. That means the confidence in which we can deliver, I could make and convince that time the chairman of ISRO, and we delivered it also. But a person to take a decision, a new person in an academic environment, to take that call where we don't have a design also, but still claim for it and do it. So that is your role now. I will infuse all of you to keep your salient points what you have to bring, and allow the learned participants here to know more about through questions. Okay? With this, I am giving.
To give a lead talk on recent trends in geoinformatics for e-governance.
Good afternoon, everybody. The topic what I have selected is recent trends in geoinformatics for governance. Well, you might be aware that this particular approach is being, I think, in most of the government projects, geoinformatics has been used intensively. And in fact, it's not only the project, but also the capacity building is also percolating among various stakeholders. So if you look at the present scenario, there are a lot of initiatives already now, if you look at my presentation, I will try to do justice to timing, but I think it might overflow also. Because geoinformatics, if you see as a whole, it takes care of almost all the aspects, right from data creation, data integration, modeling, analysis, dissemination, as well as analytics. So if you see, we are basically, I'll be covering on the approaches which are being practiced for the governance, and then a little bit concept of decision support system. We'll talk about the technology trends. In fact, there are many more, but I have only touched upon few areas which are now being practiced by most of the industry as well as the government agencies. A few initiatives by IARS and emerging application domains like supply chain management, crime, geohealth are few areas where where one can really make use of the geoinformatics tools to handle the governance. And of course, the conclusion part, that is the impact of geoinformatics in governance. Now, if you look at the geoinformatics approach as a whole, we have various components where we talk about the Earth observation system, where you have different satellites which are providing spatial spectrum mounted in various platforms, whether you talk about spaceborne, airborne, or even we are now talking about UAVs. And in fact, if you look at the present scenario, even the geophysical products are being, they have been generated by NRSC as well as other space agencies in order to help users in order to model or even provide the direct information. GNSS is also an area where I think a lot of developments have already taken place, and we have been using this technology for positioning as well as navigation. GIS, I would say that it is really providing a platform where you can integrate all these geospatial data sets together, and you can provide a lot of modeling activities, integration, irrespective of the number of layers. Ground data is also important because there is a lot of in situ measurements which are going on with respect to the sensor data collection, or you can even make use of crowdsourcing information in order to validate your data sets, or even if you really want to make use of those data sets for modeling purposes. And of course, the application decision making with knowledge can facilitate. Next. Now, when we talk about decision support system, well, if you talk about last couple of 15 years or so, decision support system was only a buzzword. In fact, there was no real-time decision support system which were developed. There were initiatives done at IARS where we developed the biodiversity conservation prioritization using decision support system, where we have used multi-criteria analysis to do the prioritization. And the same initiative now, I think, if you see Forest Survey of India, and there are so many other areas where the decision support system is being developed. And this DSS primarily addresses more on the semi-structured or unstructured problem, where you can use multi-criteria analysis and go for the site suitability. And there are even many more, and the best part of decision support system is you can develop a domain-specific DSS which can allow a lot of applications to be demonstrated. Next slide, please. Next. Now, coming to the technology trends, I have picked few areas like citizen science approach. This is one of the unique approach which is, in fact, most of the organizations are making use. The reason is that we are still looking for the real-time ground truth data. And there is an option that if somebody really wants to contribute the data, crowdsourcing, or there are so many different mechanisms to incorporate those data sets. So citizen science basically is an approach where public can be involved in order to provide the basic ground data. And in fact, if you look at the different like level 1, level 2, level 3, level 4, it all depends upon the level of contribution by the user. Because if the user is more smart and they really want to contribute more, they can be in the upper part of the ladder, and they can contribute not only in the data collection but problem definition, analysis, all those parts can be taken care of. One of the classic example is COVID-19. Well, you might be seeing that Johns Hopkins was providing a dashboard in a real-time basis, and there was a lot of data which was coming through crowdsourcing. And in fact, all these crowdsourcing data was available in the form of APIs, and one can directly load those APIs in their application, and it is available to the public. So heads off to all the crowdsourcing volunteers who have contributed the data, not only in India but also all across the world. Next slide, please. Geospatial data cube is an area where I think we have to really, all the space agencies, they have to create these type of geospatial data cubes, because here primarily I'm addressing the data cube where all the satellite data can be integrated together, and we have to really come up with the analysis ready data, which is nothing but a pre-processed data which can be provided to the user agencies. And in fact, there are few initiatives done by Google Earth Engine where they are providing a mechanism to really model those data sets. But when you have a geospatial data cube sort of application where the pre-process, or I would say analysis ready data is available to the user, then the application development can be done. Because the most of the time, whenever you have the satellite data, you spend a lot of time on pre-processing. So it's really important to have the data cubes of by various space agencies, like Australian Geospatial Data Cube is one of the classic example where they have developed this, and in fact they have also provided the APIs in order to create those data cubes. So IRS also we developed these type of data cubes for the Uttarakhand region, and the idea was just to demonstrate that how these type of data cubes can be created. Next slide. Well, there are data cubes with respect to database domain also, 4D, 5D. So those type of dimensions can directly be attached to the multidimensional data cube where you can make use of schema type data structure, and then you can directly call out the information by putting those data sets into this thing. I think just back slide. Back, previous, yeah, this one. So these type of data cubes as well as Colab in the database system can provide you the drill down roll up operation, and these drill down operation can provide analytics to your data sets. So only thing is how you store this data in the form of different data cube which is conceptual in nature, and you can provide a lot of information. Next. SDI is most of the, I think it is well-known concept where the data sharing mechanism can be incorporated, and here I think NSDI, Department of Science and Technology, is already into the initiative to develop the Indian NSDI. But the most important thing is this SDI is not limited to this. Only the data with respect to country level, you can develop state SDI, and also you can monitor the projects by making use of these SDI portals. And these SDI portals primarily, in fact, you can even directly see the monitoring of the projects can be done. In fact, this particular geo network, which is an open source tool, you can directly download and you can immediately develop an SDI for monitoring any governance related projects. So I think this is a good concept. Another area is interoperability and standard. One really has to adhere to the interoperability, because if the interoperability of the system is there, you can the data can talk to each other, and these data can be provided for to the user, and it can even be consumed. So the OGC and all those initiatives has to be taken care whenever you create these type of data sets. Next slide. Well, big data, I think it's still a buzzword, and in fact, a lot of initiatives are there, because we are handling a different type of data sets, whether we talk about satellite data, whether we talk about the data coming through social networking, the data through IoTs, so many different types of data which are structured, unstructured, or semi-structured, they can directly be integrated. The only issue with big data is you need to have a different platforms like Hadoop, all different type of other frameworks where you can integrate these different type of data sets. The problem is that you cannot rely on the conventional system because they only dwell on the structured databases. So that's why these big data frameworks can be developed, and in fact one can make use of all the existing data. It can be integrated together, and you can make use of NoSQL, MongoDB, and all those. There are so many other information which can be extracted. Next slide. This is a classic example of Twitter analytics, where we are just trying to show that how the social media data which is coming directly to the system, you can make use of this visualization of these data, and in fact you can even work on the sentiment analysis on the social networking data. You only have to create the ontologies. Once the ontologies are created, you can just develop those keywords, and you are able to get the sentiment of the user, and those sentiments can directly be captured, and you can have a good analytics on those aspects. Next thing. Geospatial AI, I think machine learning AI, all these platforms are providing a good mechanism to ultimately coming out with the knowledge base from the data. And in fact, it is not only providing the knowledge, but also it is providing a best possible processing time, as well as the hidden information can be extracted by making use of the AI-based geospatial platforms. Next slide. Location-based services with AR and VR is a new area. In fact, you might be aware that everybody is making use of location-based services, like you are making use of Google Maps in order to navigate, in order to go for localization, orientation, where I can find all those things. But now this is getting integrated with augmented reality and virtual reality, wherein you can not only, like Google Street View is a classic example, where you have the panoramic view of those, the entire data set. And in fact, I was looking to one of the presentation by one of the students. They have used the Google Street View to come up with the green area in those areas. So if you are able to capture those information, you can develop a eco-friendly routes which can be used directly because nowadays pollution is one of the most important, biggest problem, I would say. And in fact, if you make use of these tools, integrate them together, you can really come up with the impedances which can be used for better routing. I think cloud is well known. We have been making use of cloud, and in fact many the platforms are available, whether you talk about Google Earth Engine, and then you have so many other platforms. Even RGIS is also providing platform in order to make the data to be resided, and even one can even showcase other information. So cloud computing, I think, is an area where we can make use of those services. Next. Now I will try to talk about some of the use cases which we have developed, which primarily relates to the Government of India national program. One was classic example of Swachh Bharat Abhiyan. Dr. Senthil Kumar, director, at that time Director IRS, he is sitting here. So we developed this total turnkey solution, which was appreciated by almost every agency, even ISRO also appreciated, and we developed 2 mobile application and 1 dashboard. The primary idea was to capture some of the area which are not, in fact, which are not available. The data was not available related to the waste disposable sites, and those data sets can directly be captured through mobile app, and once it is captured, it directly goes to the dashboard, and from the dashboard the service mechanism can be made, because this dashboard resides in the municipality, and automatically you can assign a vehicle, you can assign a person, and the routing will be there, and this can be directly used by the service this thing. So it's a total turnkey solution, and this solution was developed as per the requirement of the municipality. So this is a classic example of this particular application. Next. 3D city models is really an important area. Yesterday we had a talk from Dr. Bharat Mohani. He told that LiDAR is being used extensively, and in fact the 3D model which I am showing over here, it has got a lot of applications. Looking at the 3D model, it is not meant for not only meant for the visualization, but also you can go for indoor navigation, infrastructure planning, 3D crystals, shadow. So many applications can be derived, and these applications can directly be linked to smart cities, or even there are some Amrut programs. So many different type of programs of Government of India is there, and you can do the semantic analysis. So you are not limited to geometry, rather you have a semantic mechanism by which you can query those data sets, and you can provide the value-added information. This is a classic example of traffic noise modeling, where we have just carried out some noise-related study where one can visualize that how the different the noise parameters are changing over a period of time. And we did a lot of measurements. We have used terrestrial laser scanner to create the 3D models, converted them into workcell, and after that we developed two-wheeler, three-wheeler, four-wheeler, different type of coefficients were developed, and we developed this empirical model and then simulated for all along this area. So this gives a fair idea that how the noise is affecting our area, and which is considered to be one of the most pollution. Geospatial solution for forest fire reporting. This is a new application we developed for Jammu and Kashmir Forest Department as well as Uttarakhand Forest Department, and recently we developed for Mexico also, because reporting is one of the most I would say it is considered to be an important area, because you are getting some satellite data at some point from MODIS or other NPP sensors. But if you have the foresters who are available in the area, if they can take a photograph, they can provide some vital parameters, then the decision making can be done. In fact, now in America, what they are doing is they are developing the IoT devices, which are called as green bots. So what they do, they install it in a particular ground area, and they are able to detect the smoke sensors. And from there, automatically the reporting can be done. So you are not limited to satellite data, rather you can make use of the ground sensor and integrate with satellite as well as these type of reporting apps, they can really take care of the storage. Next. This is Crime GIS is also an important area where you can do hotspot analysis, and it is now coming out quite well. In fact, CNTS, the government of India is having their own system, but it has got a lot of limitations. So we carried out some course and we suggested some of the things which can be incorporated in CNTS, and you are able to do all this important analysis. Next. Supply chain management is also an area where you can use geoinformatics in order to have the right from the raw material to supplier to processing, finished product, distribution and customer. Everything can be done. We in fact developed a value chain for the dairy product. Next. GeoHealth, I think I will not dwell more on this. Next slide. There are two conclusions I would like to draw from this. I think geoinformatics is playing a game changer and plays a vital role in governance, and in fact it is considered to be the backbone for the governance. In fact, let me tell you that Prime Minister of India recently announced Mission Karmyogi, where they want that everybody should try to make use of geospatial technology or geoinformatics in their overall program. So if you make use of these technologies, you can have a better decision making, you can provide a lot of insight to those applications, and ultimately integration of IoT, AI, cloud and big data can make the difference. Next, last slide. Now here, as I told, that location-based services and e-commerce, logistics and delivery can provide a better mechanism. COVID-19 is one of the biggest, I think geospatial technology really played an important role, right from contact tracing to distribution to modeling. Every aspect we could able to have through geoinformatics, and ultimately UAV, drone and all these things, real-time monitoring of supply chain as well as geospatial data policy can make the difference, and we have to really ensure that if geoinformatics is used its most potential, it can really make the difference and ultimately can lead to a better GDP for the country. Thank you so much.
Thank you, Dr. Sameer. Maybe one or two questions we have.
I am Pranjali Tripathi. I will be presenting my work on multi-criteria decision analysis based evaluation of forest fire risk zones in Pilibhit district using satellite, remote sensing and analytical hierarchy process techniques. Firstly, the forest requires no introduction. It is very well known that it is a major natural resource which plays a very important role in maintaining the environmental balance. Health of any forest is dependent on the ecological conditions prevailing in that area. Another important issue of forest is the forest fire. To manage the forest fire, it is very important to know the forest fire risk zones of the area. Forest risk can be defined as the probability of a forest fire occurring as a potential damage. Fire risk zone is an area where the fires are likely to be affected with the areas which are very much prone to forest. Therefore, forest risk mapping is essential to maintain the actions on vegetation to indicate the zonation mapping of the area as well as for forest fire management. My study area is the Pilibhit district, and I have selected this because after the monitoring of the forest fire, we found that it was the mostly prone area it was having greater than 500 fire points. That's why we have chosen this area. And secondly, it is also one of the most important part of Uttar Pradesh as it is our tiger reserve area. The objectives of my study is the estimation of extent of forest fire affected area, forest fire risk assessment and mapping, measurements of forest fire management. Now coming to the methodology. Firstly, we have taken the various data sets like the Sentinel-2A, post-fire, pre-fire satellite data and post-fire satellite data to identify the burnt areas. Then we have taken the SRTM data 30 meters, and after the pre-processing of the DEM as well as of the satellite data, we have further identified the forest type, density, bare soil index, and then we have also used we have done the digitalization as well as the visualization for the proximity, to identify the proximity to road and settlements. Then we have used the DEM data, SRTM data for elevation, slope and aspect. We have also used the meteorological data. From that, we have taken the temperature and rainfall data to identify the wet and dry months using the Omro thermic diagram. Using the ancillary data, we have extracted the population data to identify the population density of the forest fire to the affected area in the Pilibhit district. After doing all the integration of the layers, then we have identified the forest fire risk zones. After identification of the forest fire risk zones, we using the ground truth, we have done the validation by overlaying the ground truth points as well as the hotspots points like the small fire points, large fire points, and then we found the areas which we have identified as the risk zones were exactly those zones where the validation points fall. Finally, we generated the final forest fire risk map. Then I'll come to the next slide, that is the multi-criteria decision analysis. Multi-criteria decision analysis is a set of methods where we address the problems characterized by multiple and conflicting objectives. For multi-criteria decision analysis, it depends mainly on the three objectives. First one is the identification of the criteria. Second is the identification of the criteria which will be given the most importance, and lastly, on the basis of their importance, the ranking will be provided, and then finally, further output will be generated. Like my output was the first five risk zones. For other criteria like other process, other criteria are used, and for other various objectives, this method is used. Here we have used the analytical hierarchy process, in which we have used 8 criteria for this analytical hierarchy process, and we have given the preference to the criteria on the basis of the standard SATI scale, which was given in 1980. The whole analytical hierarchy process is dependent on this, as it is mentioned, if the criteria which are of equal importance, they are given the intensity of 1, which are of weak importance over the another, they are given the intensity of 9, and which are of intermediate values between the two and adjacent judgments, they are given the criteria at 2, 4, 6, 8, and then we calculate, after giving the preferences, we calculate, I have identified our first one is the forest type, forest density, bare soil index, population density, settlement, road, slope and aspect. I have given the most preference to the proximity to road and settlement, because in Pilibhit district, most of the fires are caused due to the anthropogenic reasons. That's why I have given the most preference to the proximity to the road and settlement, followed by the forest type, density, bare soil index, and so on. Then this is the these are the criteria. For doing the forest type, we have used the hybrid classification. It has an anthropogenic reason for forest fire. We have used this criteria, where we found 2 to 6 2 persons per hectare to 23 to 71 persons per hectare. Then the bare soil index, as it is in this, I have used this index because bare soil index is also one of the important factor, because if the areas having the higher bare soil index, in those areas the density will be low. So wherever there will be the density low, then those areas will be prone to the grassland, and grassland prone areas will catch fire more easily. Then next is the proximity to settlement and road, as I told earlier. Then next is the slope, followed by aspect. Slope and aspect was were not more important for my work, because the Pilibhit region is kind of a plain region. That's why these were not as more important as other factors. Then finally, after integrating all these factors, we generated the pairwise comparison matrix, which is shown here, where we are given the importance, and then after getting the pairwise comparison matrix and integration of all the layers, we have found final forest fire risk zone map. Next slide. These are the maps of the 8 positive factors which we have identified for the forest fire risk zones. And this is the validation map. After identification of the forest fire risk map, we have done the validation by overlaying the fire points along with the ground truth points. And we found that in the validation, we found that the areas which were more prone to the forest, which we identified as risk zones were more prone to the moderate region. Higher regions are shown in the red and orange are the moderate ones. In Pilibhit, we found that moderate were 51.57% and higher fire risk zones were only 34.15%. Also, I would like to mention the significance of my work is that it is very important for the sake of forest management. If the forest personnel are well known about the risk zones, then it will be easier for them to manage those areas which are more prone to the forest fires. That's all. Thank you, and these are the references.
Thank you, Party.
The properties which are collecting less tax than they should be collecting, and unassessed are properties which are not collecting tax at all. So how we are doing this is basically we are using geotagging, which is just process of appending geographic coordinates to any media or any additional information using a location service from the mobile device. And then geotagging, so for geotagging each property, the field officials has to go in person to the property, thereby we can verify the correct information in the field itself. So that when you go back to your database, it should be very proper. So we are also using geofencing concept here, which actually creates a virtual parameter for the real world geographic area. So suppose there is a building with multiple floors or multiple portions,
Can we talk after
we
1 hour?
actually geotag the building, and then each portion or floor we geotag it separately, and we use geofencing to connect these two property and the floor details, portion details, so that they are connected and creating a parent-child connection. So properties have further been classified into residential, commercial and mixed categories to collect address, trade information or floor plan details as per the commercial data or the residential data. So we have also provided a facility to link the water connection information, so that if for any property there are 2 water connections or there is none, those kinds of linkages should be streamlined, and we have to detect any irregular connections. So this is these are the pictures showing field officials of CDMA actually going to each property and geotagging them. So I'll just give a sample of how this works. So we actually collect data from all the ULBs. So there are almost 140 ULBs now in Telangana. So we collect all the base data without any location data from each ULB, and then we send these data to the registered user for a particular ULB, so that he can only geotag the properties that are in his ULB, so that we are actually transmitting this data to his mobile, and his mobile he can go to the property, geotag the property and add these additional information like address or trade details or floor plan details, what is the area of the building, how many floors are there, all this information he can add there, and then he can upload it to Bhuvan servers. So once these data is uploaded to Bhuvan servers, we are actually mapping them. You can see it in the bottom. So these are mapped on a map visualization software in WebGIS. So till now we got the data. So but we need to again verify this data whether it is correct or not. So for this we are using some 5 levels of user hierarchy. So whatever bill collectors, that are the field officials from the CDMA department, So once they are geotagging this, so the revenue officers of the particular ULB will be moderating all those geotags to check whether whatever information that the field official has collected is true or false. And then whether if the information is wrong, those will be moderated and rejected, and these people of the field officials will go back and assess it again. So thereby we are adding one more step to collect the correct information. So that's how we are collecting the correct information. So now what we are doing with the correct information is we are linking this data back to the ULBs, source ULBs, so that they can link with other departments as well. So if there are some property issues in any assessment, those also will be linked with other department data, and all these transfer of data are happening through web services to promote e-governance. So once this data is available with a particular ULB, they are also available in the public domain, so that people of that particular ULB can check their data whether it is accordingly verified or not, and they can get it corrected. So this project is done in 2 phases. So in phase 1, what we did was we collected all the property details as a single unit. So, but recently we have started phase 2 of the project, where what we are doing is we are using this geofencing concept to collect each individual unit with multiple floors and portions, and we are linking the water connections and trade details as well. So these are the examples of the phase 1 and phase 2. And you can access these live in the public domain. You can just search for Bhuvan CDMA in Google, and you will be able to access these portals. So this is these are few examples in Karimnagar Municipal Corporation, where you can see that their previous MIS data are showing it as a residential complex, but it's actually, you can see the image to be clear, as a commercial complex, and the number of floors is also properly mentioned in the new Bhuvan data, which was not the case earlier. So these are some kind of examples where this application has been very useful. So these are the phase 1 statistics. We have almost geotagged 12 lakhs assessments across Telangana in 72 urban local bodies under 31 districts. In this, almost we have found out 20,000 unassessed properties, that are new properties that are added to the MIS system. And along with that, we have found out approximately 2 lakhs of under-assessed properties. Under-assessed properties means they are collecting less tax than they should be. So from this project, Telangana government, Telangana CDMA has almost collected 27 crores of extra revenue for the past 2 years. So this is phase 2 statistics, which is ongoing. Now in the phase 2, they are almost collected 16 lakh assessments in 140 ULBs. So they extended the program to other ULBs as well. So in this, we have actually worked with different CDMA departments and NIC departments of the state department as well. So coming to the benefits of the project, as I've already told you, we have a basic review of all the properties for tax assessment and for under-assessed and unassessed assessments. And we are also including this provisioning water tap connections and assessments to eliminate any duplicates in the MIS data. And there we are also including the new trade licenses under the department MIS. We are also sharing all these data through web services for all the
Respected Chair, good afternoon, all the dignitaries here. Provide the technical reports, tools and results to the decision makers to take the decision. So this is for us, I'll take it forward, such a word. And this is one of the emerging Industry 4 ready technology we have taken off. And the operation area is very small. And I'll try to show that how we have come to a conclusion and how it has, the decision has been taken, I can say, within couple of hours and 1 day or 2 days. You can say that I will come to them. So this has been done with a team of scientists from APC. Going for our lunch, there will be lots of waste coming out from after we take the lunch. Those goes as a solid waste there. And this is where after the bifurcation happened, there lots of migration happened from here, Telangana to Andhra. So the Vijayawada was identified as one of the more the important urban area where the settlement started expanding. And there was a location where having house for all, and the government decided to have around 150 plus house to be given on a vertical structure. And beside that was this solid waste dumping out was there. Government has to decide that how to excavate all the solid waste and dump somewhere, and that there comes this problem, and how to estimate it and to give it for biomining so that it can be utilized properly. So case came to us, and this is the study area what I want to show. You can see these are the areas where this solid waste dumps are there, and these are the high-rise buildings by Prime Minister Awas Yojana it came up. So you can visualize how near or proximity is there near to these housing areas. And it was a really challenge, and it was in this very popular area, Ajit Singh Nagar in ward number 42 and 43. So, and I just want to show this one because you can see the area before this expansion. You can see this is a railway track, and
I've already said to call me after 1 hour, please.
The town started expanding.
Ashwini had called and I had said that you should call me after 1
This is
hour.
the solid waste town.
Right now in
And
a
this is
meeting.
22 years.
Hello?
We cannot
Yeah,
bear the
right.
smell and odors.
Right now
and
in a
all the
meeting,
environment
I had
issue
said to
happens
call
if
after
the
1
solid waste down for 1 day, 2 day, 3 days. It's a
Yeah.
22-year-old, 22-year-old, and it was legacy waste, you can say. So challenge was to take it out. I just can have a close look at here. Here is a water treatment plant, and these are the areas to be evacuated. Challenge was to estimate the volume precisely. I'm using this word precisely because it was the challenge, because every measurement was leading to some of the cost component, and government has to pay for it to the industry company to biomine it. So there was every volume had a cost component. So this was the where we thought of having a precise measurement, and that's the reason FSR came into picture. And we have to define a standard operating procedure so that further anywhere this happens in government, it can be utilized. And further, we thought of doing a cost benefit analysis that there is how the new technology is better than the rudimentary technology of surveying and estimating the volumes and other things. So this is the flow chart methodology what we adopted here, site preparation, site visiting, EAB mission planning, identifying where we can establish our control points and where we should do our volume estimation, cross verification, validation and processing, and in collaboration with the user department. Subsequently, we will be understanding the methodology. These are the control points where we fix it. There are around, this area is totally around less than 1 square kilometer, but we mapped almost 1 square kilometer. You can see almost we have established 6 ground control points. Within 1 square kilometer, we have established 6 ground control points because we have to do precise measurement of each of the units. That was the challenge, that's why we established. You can see the locations here, and these are the field photos. Then we transfer to correct this high resolution, I would say very, very high resolution images. We need to be very precise in correcting those images. So we transfer the ground control point, primary ground control point of Serve of India, which is near to Gannavaram Airport, Vijayawada. We transfer that is for 30 kilometers to our base station here. It was transferred there, and further it was our local base station was established. Then the images were captured so that the ground control points are visible in our images. It can be rectified properly. So we followed almost end-to-end, end-to-end workflow for this one. And these are the vital statistics I am showing here. Almost around 1 square kilometer we flown, and images collected with 64 megapixel camera, RGB camera around 500 plus. Almost we got resolution of 12 centimeter with fixing by 4 centimeter GSD per pixel. RMS error was less than pixel, you can see, and we almost got 18 crore ground cloud points, dense cloud points to be classified to get the result. So 1 square kilometer you have got so much volume data to classify and do image processing. And this is what I want to show, that you can see the core area or the boundary area, none of the images none of the images is distorted. You can see, and there is overlap more than 9 images at any point location you can pick. We have got more than 9 type points for each of the positions. So correction parameter were taken care when we flown the data drone and we got the result. And this is the more critical part of the cream of our analysis. Once you get the cloud points and do the analysis, you get this digital elevation model. But our focus was not to get this elevation of the buildings. Our focus was to get these locations where we are building volume estimation. So we classified all the cloud points, and the cloud points after reconstruction, we got all the buildings or height parameter. You can see 56 meter height, all the things were reconstructed and normalized. And now these sections of solid waste management dumping sites were visible properly with this elevation parameter. Then we did our analysis. This is where the result was derived. We referred the manual from Ministry of Urban Development. This manual tells that there may be variety of solid waste and their volumes are different. But here, being it is 22-year legacy waste, the expert judgment, expert opinion from the municipality department told that we may get all here. So we have to standardize it. We took a conversion factor of 0.7 metric ton per meter. So with that, we have calculated this is the volume what we have estimated for all the 9 sections. And you can see, if you are calculating all the volumes per section wise here, without going, I'll complete in 2 minutes now. Without doing any downfill, we are getting around 36,000 metric ton of solid waste to be excavated. But being this is not legacy waste, it was decided to do a down cutting of that around 3 feet. 1 feet downfill will cut it. So 1 feet will be sufficient. So final volume estimation came that it's something around 55,000 metric ton of volume to be excavated. But we have not stopped here because we have to submit a technical and scientific report so that it goes to legal issue. It should be challenged. If user should be in a position to answer it. So what we did, sir, we have done the ground validation and checking of for our results as some of the control points, and we verified in the field also that where we stand, our results are satisfactory or is precise measured or not. So it came to a very satisfactory. You can see these results from deviation from the actual, and we did a cost benefit analysis of the rudimentary survey, what department had earlier and what we did, sir. That is where we stand for doing a precise measurement, delivering the user a result which can have a direct cost benefit, sir. 2 to 3 weeks they spent for calculating the volume, and the volume came around 1.85 lakhs metric ton. Whereas the actual volume when we did this measurement, it came around 55,000. So there is a difference of 3-4 times it was estimated earlier, and I'll just go to my conclusion side. I'll focus on these slides more. You can see this precise measurement has saved the department almost 15 crore rupees, sir, for this area of 1 square kilometer only with the advanced technology what we have used. And by spending only 7 days to 10 days, sir, maximum. And the result is for a 1 square kilometer area, if you can save 15 crore rupees for a municipality authority, it's different, has more impact. And what we suggest here that we have remote sensing, satellite remote sensing, and this is coming on UV remote sensing. Study that area and do the survey. It has given go ahead for, it has given them very good scenario for clean water and sanitization. Sustainable city and community SDG 730 is SDG 11. And we have partnered with the government decision making process for achieving goals. So it is 17. So we are satisfied with the scientific community that we are able to achieve with this new technology at least 4 SDG goal for a small area, and we have saved lots of cost for them. And it was really an amazing experience to be part of it. And these are some of the references what we have used.
Governments, because governments cannot do this. As a consultant, some of you, the youngsters sitting there, has to take up. Thank you once again for your presentation. Sorry I didn't allow any questions to come because all the studies It is the consultant entrepreneurs which has to take it up and then do, and also thank the lead talk which has given lead to many of the things. Keep doing. There are a lot of future for all of you, and thanks for the opportunity given to me by the